just climbed out of a cottonwood tree. Well, I was running from some honeybees, drip drying in the summer breeze. After jumping into Calico Creek, I was running down an old dirt road, past a field that had just been mowed. Man, I wish you would left me alone. Well, I was almost home. So, thinking about having a music career too, since I'm doing all this videotaping and recording, and might as well, right? Maybe I should start each video with a song. Maybe I won't torture you. But anyways, you're saying, wait, you're getting to calculus. You're going to be torturing me. Okay. Anyway, when I left off the previous video, I said you're either going to get an answer or it's going to be indeterminate. So if you recall that that 0 over 0 is indeterminate, means do more work. And I said, well, we got to do something else. Well, what is the more work? Well, I'm going to show you. We have 3 techniques for solving this. The last one is the most powerful of them all, but you can't learn it yet because you need to have more skills. You need to have the ability to take derivatives, and that's called L'Hopital's rule. But that will come later. So we'll revisit limits throughout the sections because the limits actually describe what's going on with the derivative and integral. But we're also going to learn how to evaluate indeterminate forms of limits using L'Hopital's rule, but that's later. So the first one is dividing it out. But let's first double check that this is an indeterminate form. We're going to plug a -3 in. That's our go-to method. Hey, I wanted red. -3 squared minus or plus a -3 minus 6 all over -3 plus 3. Well, this is 9 minus 3 minus 6 over 0, so it's 0 over 0. Indeterminate. There, indeterminate. So we need to do more work. So what is this dividing technique? Well, this top is a trinomial, and you need to factor it. So you guys got to be good to brush up on your ability to recognize that this is easily factorable. So it's going to be x plus 3, x minus 2. Should be able to do that in your head. And then all over x plus 3. I'll leave this here. So this is equivalent, when you divide this out, to the limit as x approaches -3 of just x minus 2. The functions are not exactly the same, meaning if you graph this whole function, there's a hole. Where's the hole? At -3. So it's the same thing as if you graph this. So if you have x minus 2, you have your graph, and this thing would do something like this, right? But at x equal to 3, you would have a hole on this graph right here. So this one would not have that hole. So that's the difference. So they're not the exact same function, but the limit, this limit is the same as this limit, okay? Because that hole does not stop us from having a limit there. So what is the limit? Now you can just fill in. -3 minus 2, -5 is our limit. Okay? So at -3, oh, that's not where our hole is, sorry. Our hole is down here. Oops. So at -3, our hole is there. Sorry. So what is our limit there? And it's -5 is our limit there. Okay? So, good one. Now let's try this one. We're going to fill in. Let's fill 0 in. That's 0 minus 0 all over 0, which is 0 over 0. Okay? Okay, what can we do about this one? Well, we can factor out an x. So this is x minus 3 all over 4x. And this is the equivalent to the limit as x approaches 0. And we can cancel out this x. So we're left with x minus 3 over 4. The limit as x approaches 0 of this. So now we can fill in a 0. And it's 0 minus 3 over 4 or negative 3/4. Okay. All right, one more. Let's get a new color. Ooh, purple. Okay, so this one is going to need something else called rationalizing the numerator. You see this radical here. There's a good chance I might be wanting you to rationalize the numerator, but we'll get to that in a second. We still got to plug 0 in to give it a try. 0 plus 1 is this, so is the square root of 0 plus 1 minus 1 all over 0. And that is equal to 1. The square root of 1 is 1. 1 minus 1 is 0 over 0. Do more work, which is because it is indeterminate. Yeah, indeterminate, there we go. Anyways, what do? What is rationalizing the numerator? And usually you've seen it as rationalizing the denominator because to simplify a fraction, we say that there should not be a radical in the denominator, so you rationalize the denominator. Well, in this case, we're rationalizing the numerator. Okay? So we're going to have to multiply by the conjugate of this up here. So I'm going to rewrite this here. Maybe we'll get a different color. Right. Happy little blue radical. Yes, see my Bob Ross impersonation there. Happy little radical. Okay, and now I'm going to put a happy little x down here, you see? And now we are going to put a happy little conjugate in there, and it will rationalize the numerator if we do it correctly. All right, so let's do green. We're going to multiply by the square root of 1 plus x plus 1. See, this is like a z, whatever you want to call it, and then plus 1, we won't, that's minus 1, so it's plus 1. All over, it's going to be a form of 1 we're multiplying by. So basically you switch this sign. This is the same, you switch the sign. So now when you multiply out, everything in here must be multiplied by everything in here. So this times this gets us x plus 1. This times this gets us plus 1 radical x plus 1. This times this gets us, sorry, I do these arrows, and it's this times this. Maybe I use a different color. It's this times this, and this times this. Everything in there must be multiplied in everything there times there. This times this, and this times this. Sorry about that. Get back to our happy little green. So we're on this times this. So that gives us minus 1 times radical x plus 1, which those cancel each other, which was the whole point of multiplying by the conjugate. And minus 1 plus 1 multiplied together is a minus 1. All over, and you don't have to multiply the bottom out, just leave it as x times parentheses radical x plus 1 plus 1. Just leave that bottom there. So there we go. We need a little bit. Ooh, we're running out of room. Ooh, maybe we should erase this here. Give us more room. Okay, so now we have this x plus 1 minus 1 all over x times parentheses x plus 1 plus 1. A lot of plus 1s in there. Well, those cancel, so it's simply just x over x times radical x plus 1 plus 1. Now we can do our substitute in. Let's put a 0 in. We're almost there. Rounding third and heading for home. Let's do another little green. So we plug a 0 in, that's 0 over, that would be inside here is 0 times, what did I do wrong there? Oh, I'm stupid. Oops, I made a mistake. Just bear with me. I needed to cancel one more thing out. Look at this. This is the whole point of this, to cancel that x out. So look at this x and look at this x. Look at the two x's here. It's here and here, okay? And, oh, my thing's in the way. Hold on, sorry. Ooh, ooh. Picture's in the way, sorry there. So look over here at this. Okay, what's happening here is you have an x and you exit x here. So this is really x times 1, right? So it's 1x, right? Well, when you cancel this, you could cancel this, and you are left with 1 over radical x plus 1 plus 1. There. So it's the limit as x approaches 0, and you there. And so then we will fill in 0, filling into here gives us 1, and the square root of 1 is 1. 1 plus 1 is 2, so it's 1/2 is our answer. Okay? Very good. We'll do, if you want, you can stop this, but if you want to see another example, I'll find another quick example here, pause it and find a quick example, and then we will continue. Okay, and we're back. We're going to do this example, and actually we might do one more. That's the algebra gets a little bit much, but it's not bad. But let's deal with this one. This is very similar to the last one. And so we're going to, when you fill a 4 in, you get 0, and right here you fill a 4 in, you get 1. The square root of 1 is 1. 1 minus, what are we doing here? 4. Oh, 9. Sorry. Fill a 4 in, that's 9. Square root of 9 minus 3 all over. And we're filling a 4 minus 4. So this is 0 over 0. So yes, indeterminate, we must do more work. So we're going to rationalize the numerator. Okay, x plus 5 minus 3. I'm just rewriting it. And we're going to multiply by the conjugate. What is the conjugate? The conjugate is square root of x plus 5 plus 3. And what you're going to multiply by a form of 1. Okay. And you're going to multiply this out. So it's just this times this, this times this, this times this, and this times this, right? So when we do that, you get this times this is x plus 5, because it's square root of x plus 5 times the square root of x plus 5. That's square root of x plus 5 squared, and the square root destroys, just undoes the squared, so it's that. But we'll keep that in parentheses, which is good. So this times this is plus 3 square roots of x plus 5. This is minus 3 square roots of x plus 5, and that's minus 9. All over, it's minus 9, and it's all over this times this. So just leave it like this, and this is square root of x plus 5 plus 3. Okay, now these cancel. That's always going to happen if you multiply by the correct conjugate. And you have x plus 5 minus, in parentheses, minus 9 over this. Now, at this point you're like, what? You need to cancel something. So you're looking like, oh, I cancel this. No, not even close. You cannot do that algebraically. If you're ever confused about something algebraically, you need to ask. But we can, look what we can do. What's x plus 5 then minus 9? Well, that's x minus 4. X minus 4 in parentheses times the square root of x plus 5 plus 3. And guess what? Oh! Now that's not a 0. Once you cancel that out, that's a 1 up there. So you're left with 1 over the square root of x plus 5 plus 3. Okay? So now you got to evaluate the limit. So we want the limit as x approaches 4 of 1 over the square root of x plus 5 plus 3. You're always looking to cancel something out. Even when you're rationalizing the numerator, you rationalize the numerator, try to cancel something out, and then plug your number back into it. When we plug it in now, it's 1 over, and it's the square root of 4 plus 5, which is 9, plus 3. That's 1 over 3 plus 3, or 1 over 6. So the dividing out technique, that's what we're doing, but we're rationalizing the numerator first, and then trying to divide out something. So the limit, this limit up here, this whole thing, it's 1/6. Okay, we have another one, and we're going to do another one here. And I'll set it up, and give me a few seconds to set it up, and we will be ready to go. Okay, we're back for one more video. And this is still trying to cancel something out, but you still got to first try. Always try, plug it in. So we plug a 0 in, that's 1/3 minus 1/3. And then fill in a 0 down here, and that's 0, 0 over 0. Okay, we need more work. Must indeterminate. So what can we do with this? Well, I see this as messy up here. Let's combine that. Well, how can we combine that? Well, we have one, we need to have the same denominator in order to add or subtract fractions. Okay, so we have this, and so I'm going to multiply by this fraction by a form of 1, and it's going to be 3 plus x over 3 plus x. I'm allowed to do that with just this piece here, and here I'm multiplying by 3 over 3. Multiplying by a form of 1, okay, multiplying by a form of 1, okay, so this ends up being 3 over 3 times 3 plus x minus 3 plus x over 3 times 3 plus x, all over x, because we didn't touch that. Okay, now we can subtract those two, but remember, it's subtract this in parentheses. Be careful, this minus sign applies to both of those pieces up here. So this is 3 minus 3 plus x all over 3 times 3 plus x all over x. So let's just simplify this. That's why we got a common denominator, so we could do that. So this is the bigger fraction bar, sorry there. Well then, what is this? This is really 3 minus x. See how I did that? Minus 1 distributed into both places over 3. And if you wouldn't have to, if you understand all these steps, you wouldn't have to show every single step that I'm showing. Okay, some steps, yes, but not all steps. If you could have just jumped to the chase if you understand. But I'm doing that just to be thorough. Okay, so 3 minus 3 is 0. So we're left with a negative x over 3 times 3 plus x all over x. Now, this whole division, remember division is the same as if you invert and multiply, if you want to think of it that way. So this is really this problem right here. Ooh, let me change colors there real quick. It's getting a little, that's not an efficient. All right. So, change back to red. So this is 3 over 3 times 3 plus x, and instead of divided by, you're multiplying by the reciprocal. It's the same as this. So then what we can do is we can cancel this, and we're left with a negative 1 over 3 times 3 plus x. So there we go. Now it's this limit. So let's just rewrite the limit real quick. It's the limit as x approaches 0 of 1 negative 1 over 3 times 3 plus x. This limit is equivalent, this limit right here is equivalent to this limit right here. And now we plug in, and when we plug in a 0, that's 3, so negative 1 over 3 times 3. So the answer is a negative 1/9. Okay? Awesome. Let me email me if you have issues or questions. Thank you.